Example 5.3 part A wants us to find the f plus g and state the domain for f plus g. And there's a little redundancy here because it's not possible for us to be able to find f plus g without also finding and stating the domain. So there's two things here that we're going to box in the final answer. But let's start with looking at f plus g. Now it does say here, it says let f and g be functions with unspecified domains. So what that means is that I'm not giving you the full function definition. All I'm giving you is just the equation. So let's start with those. F of x plus g of x. This will be the square root of x plus 4 plus the square root of x minus 1. Now ideally when we're adding and also when we're subtracting two functions together, we're looking to combine like terms. And fortunately or unfortunately, however you want to see it, there is no like terms here. Each one of those square roots is a different square root. One of them's the square root of x plus 4, the other's the square root of x minus 1. So as far as the equation is concerned, the equation is already as simplified as it's going to get. So we're going to leave that alone. So really the bulk of the work in this particular example is in finding the domain. So we have to be thinking about what's the domain of f, what's the domain of g, and then the domain for f plus g by definition is the domain of f intersected with the domain of g. So there's no way to get the domain of f plus g without first knowing the domains of f and g separately. So as I look at the domain for f, I'm going to be focusing on the x plus 4 that is underneath the radical there. So what we've been doing is taking whatever expression is under the radical, set it to be greater than or equal to 0, so therefore x must be greater than or equal to negative 4. And we would write that in interval notation, negative 4 to infinity. Domain of g can be done similarly. We're looking at x minus 1 as the expression underneath the radical. So if we take x minus 1, have it be greater than or equal to 0, then we would get x is greater than or equal to 1. And that can be written in interval notation as well, from 1 to infinity. Now the idea here is that we want to intersect these two domains together to get the domain for our new function. So I'm still going to be using a illustration approach. So let me draw a number line. We'll call this 0, positive 1. Over here to the left will be negative 4. So I'm going to illustrate the domain of f. It's going to start at negative 4, and then it's going to go everything greater than that. So we'll go off to the right. And let me use red to illustrate the domain of g. It's going to start at 1 and then go everything greater than that, which is to the right. So the intersection, remember, is looking for the overlap of these two intervals. And the overlap is actually identical to the domain of g. So we'll say that the domain of f plus g is also going to be 1 to infinity. So that's one of the things that we're supposed to be boxing in, because we're supposed to state the domain of f plus g, but we also are told that we need to find f plus g. So when it says find f plus g, it's really asking us to define the function. And in order to define the function, we need both the equation and the domain. So we have everything that we need. Let's just put it all together. The name of this function will be f plus g. The domain we just calculated for this function will be 1 to infinity. That's what maps to other real numbers, given by f plus g of x is equal to the square root of x plus 4 plus the square root of x minus 1. And that's the last thing that we have to find here to fully define f plus g.